Jupiter, the most extreme planet in the solar system. Jupiter is a turbulent world of monster magnetic fields and endless megastorms. Generations of astronomers have tried to solve the mysteries of Jupiter. Finally, NASA's Juno probe is revealing new evidence that unlocks why this planet is so savage. What mysterious energy drives Jupiter's eternal storms? And what powers the biggest magnetic field of any planet in the solar system? We plunge into Jupiter's atmosphere and reach deep into its core to reveal how it grew into the solar system's fiercest planet, and investigate whether this alien megaworld even unlocks the origins of life on Earth. One planet in our solar system dwarfs all the rest. Jupiter. Made almost entirely of hydrogen and helium, Jupiter's mass is 1,300 times greater than Earth. Jupiter isn't just big, it is also extreme. Jupiter has a magnetic field so powerful that it tears away charged particles from its moons to make supersized aurorae at the poles. The temperature at the center of the planet is 41,000 degrees Fahrenheit. That's hotter than the surface of the sun. Astronomers have studied Jupiter for centuries, but its biggest mysteries still confound them. Why is Jupiter so extreme? What are the hidden processes that drive the planet's ferocity?
3, 2, 1. Ignition and liftoff of the Atlas V with Juno on a trek to Jupiter.
In 2011, NASA launches mission Juno to unlock these mysteries. The Juno probe carries a suite of super advanced instruments: a particle detector, infrared and ultraviolet imaging, and a magnetometer to peer deeper into Jupiter than ever before. Juno arrives at Jupiter in 2016. The probe's onboard camera beams back to Earth spectacular images of the surface of this megaplanet. These swirling bands look tranquil from orbit, but it's a different story up close. The wind speeds inside these bands reach 370 miles an hour. Winds this strong twist the gas into super cyclone. The largest of Jupiter's storms is the famous Great Red Spot. But a riddle remains for Juno to solve. What powers the planet's megawinds and superstorms? Astronomers believe that measuring the depth of the storm bands on Jupiter could reveal the source of the mysterious energy that drives them. The sun powers the weather here on Earth. Its radiation penetrates the Earth's atmosphere and heats the surface of our planet. It is this heat that drives the range of weather we experience. Traditional telescopes cannot see through the colorful, swirling bands wrapped around Jupiter. So astronomers cannot tell exactly what source of energy drives Jupiter's extreme weather. Juno uses Jupiter's own gravity to measure exactly how far the storm bands reach into the gas giant. The density of the storm bands affects Jupiter's gravity. This gravity changes Juno's velocity as it passes over the planet. Denser areas with stronger gravity pull the probe inwards. Areas of weaker gravity release it outwards. By plotting the shifts in Juno's orbit, scientists build up a super accurate density map of Jupiter. Scientists can gauge the true size of storms raging through the planet's atmosphere by measuring Juno's speed.
As Juno moves around Jupiter, we can measure tiny changes in its velocity, and those depend on changes of the mass of the planet underneath it. So by measuring the speed of Juno as it travels, we're actually seeing the different masses of the different storm bands on Jupiter.
The more massive a storm band is, the deeper it extends into Jupiter. The measurements that Juno takes reveal that these bands reach 1,800 miles into the planet.
What Juno is showing us is that these things go very, very deep, surprisingly deep.
The huge depth of the storm bands is an important clue in solving the mystery of what drives the extreme weather on Jupiter.
Here on Earth, the weather is controlled by energy from the sun. That's what powers it. Jupiter is 5 times farther away from the sun than the Earth is, and its atmosphere is super thick. So it can't be energy from the sun that's powering all these storms.
What is the mysterious source of energy that powers Jupiter's megastorms? And how does this gas giant produce the largest magnetic field of any planet in the solar system? Jupiter is the biggest and most extreme world in our solar system. NASA's Juno probe reveals that Jupiter's megastorms stretch 1,800 miles into the planet. But the sun is too far away for its energy to power winds this deep. Researchers in Marseille, France, run innovative laboratory experiments to find out. This tank holds 130 gallons of water and tens of thousands of fluorescent plastic beads. These beads represent the gas in Jupiter's thick atmosphere. The researchers spin the tank to mimic Jupiter's rotation. Powerful pumps at the bottom of the tank blast the water. This simulates energy that radiates from inside Jupiter. A camera tracks the precise movement of the beads. The beads arrange into alternately spinning bands. And these bands are very deep, just like the real storm bands on Jupiter. The researchers believe these results show that a huge concentration of heat energy inside Jupiter could be what is driving the planet's extreme weather. Astronomers think that the way Jupiter forms 4.5 billion years ago unlocks why the planet is so hot. A disk of gas and dust surrounds the newborn sun in the early solar system. This is where protoplanets form. Gravity brings together vast amounts of matter to form the core of a proto-Jupiter. The young planet captures vast amounts of hydrogen and helium gas. This cranks up the pressure inside it. The weight of the gas pushes Jupiter's inner pressure to over 20 million times that of a car tire. This pressure superheats the planet's core. Astronomers believe this supersized hot core unlocks the mystery of why the weather on Jupiter is so extreme. Reaching deep inside Jupiter, reveals how the planet's superheated center drives its violent weather. In the core, temperatures reach 41,000 degrees Fahrenheit. That's hotter than the surface of the sun. The heat radiates to Jupiter's outer layers in vast convection currents. These warm the atmosphere from the inside out. They drive roaring winds in the cloud tops and create Jupiter's iconic storm bands.
The interior of Jupiter is very hot. This is actually heat left over from its formation 4.6 billion years ago. Because Jupiter is the most massive, the biggest planet in the solar system, it has the most amount of heat available to power these gigantic storms.
Jupiter's super hot core unlocks the mystery of what powers the largest storms in the solar system. But Jupiter has more puzzles to solve. NASA's pioneering Juno probe carries a special infrared camera. It sees parts of Jupiter that are invisible to other types of camera. It captures this mysterious image. The picture shows a huge aurora at Jupiter's south pole. It is larger than the size of the Earth.
We knew Jupiter had aurorae. We've seen these using Hubble. What Juno showed us is the size and scale and power of Jupiter's aurora. They are far larger and far more powerful, far brighter than anything we've ever seen on Earth.
Aurorae occur on Earth when charged particles from the Sun slam into our planet's magnetic field. Some of these charged particles, called ions, funnel down towards the Earth's north and south poles. The result is a spectacular light show like the aurora borealis. The Sun is too far away from Jupiter for its ions to create the aurorae that Juno sees. Instead, the ions come from Jupiter's fiery moon, Io.
Io is the most volcanic body in the solar system, and it's also a small body. So when it erupts, not all the volcanic material falls back on Io. Some of it goes into orbit around Jupiter, and some of it actually follows Jupiter's magnetic field lines and collides with Jupiter's atmosphere at the poles, causing aurora.
Jupiter's supersized aurora means that the planet must have a supersized magnetic field. And this creates a big mystery for planetary scientists to solve. Planets like Earth have a churning ball of molten metal at their core. This moving liquid metal acts like a dynamo. It generates a magnetic field that stretches out into space. Jupiter is a gas giant made almost entirely from hydrogen. Scientists believe that it contains no vast reservoir of liquid metal. So what inside Jupiter creates the planet's mega magnetic field? And why does this gas giant have not 2 poles, but 3? NASA's pioneering Juno probe confirms that Jupiter has the largest magnetic field of any planet in the solar system. Jupiter is made almost entirely of hydrogen gas. So what inside Jupiter acts like a dynamo to create the planet's mega magnetic field? Scientists at the Lawrence Livermore National Laboratory believe that the huge pressure deep inside Jupiter unlocks the mystery. Here, they use powerful lasers to simulate how this pressure changes gases into weird new states of matter. The scientists trap a sample of hydrogen in a chamber and then focus their lasers onto it. This creates shock waves that for a few billionths of a second simulate the extreme pressure inside Jupiter. The atoms in the hydrogen are squeezed together so tightly that its properties change beyond recognition. The hydrogen transforms from a clear gas into a substance that reflects light, a telltale sign that it now behaves like a metal. Scientists believe that a similar superpressurized form of hydrogen exists inside Jupiter. This weird type of metallic hydrogen solves the mystery of what generates the planet's supersized magnetic field. Materials that conduct electricity can generate magnetic fields, and Jupiter's massive size means that it could contain a vast reservoir of this bizarre form of hydrogen. Deep inside Jupiter lies an ocean of shiny metallic hydrogen. This form of hydrogen might make up as much as 50% of Jupiter's mass. The planet's rotation spins the metallic hydrogen. This movement creates electric currents and a dynamo that generates the largest planetary magnetic field in the solar system. The magnetic field is so large that it envelops Jupiter's moons. It pulls charged particles from these moons to Jupiter's poles. These particles slam into the planet to create Jupiter's spectacular aurorae. Jupiter's super powerful magnetic field creates one of the most stunning light displays in the solar system. Juno carries a magnetometer as part of its suite of super-sensitive instruments. The magnetometer creates the first detailed map of Jupiter's massive magnetic field. This data reveals something extraordinary. Jupiter's supersized magnetic field is a mess. Juno shows that Jupiter's magnetic field points outwards from the planet's North Pole and inwards to its South Pole. But a portion of its magnetic field rejoins Jupiter at a circular spot close to the giant planet's equator. It looks like Jupiter has not 2 poles, but 3.
Imagine going camping on Jupiter. How could you use a compass to get around when there's 3 poles? It just doesn't work.
What mysterious process going on inside Jupiter creates this weird anomaly? The super-sensitive instruments on board Juno reveal a clue. They show that many of the largest, most violent storms on Jupiter are near the planet's equator.
Juno has revealed to us that Jupiter has many storms going on at all times. The most famous of which is the Great Red Spot, which has lasted for centuries.
Jupiter's surface spins fastest at the equator. Juno measures wind speeds in some equatorial storms in excess of 300 miles per hour. Scientists believe that the winds inside these mega storms unlock the mystery of what produces Jupiter's weird magnetic field. 1,800 miles beneath the surface of Jupiter is an ocean of metallic hydrogen. The winds raging across its surface are so powerful that they create fast-moving currents in the liquid metal. These currents upset the balance of Jupiter's dynamo. They shift and shear the giant planet's mega magnetic field and create a third magnetic pole near the equator. Only on a planet so weird could super-fast winds change a magnetic field the size of the sun.
Every planet's magnetic field is a little strange. They all have their little quirks, but nothing like this has ever been seen.
The data from Juno unlocks the mystery of Jupiter's weird shape-shifting magnetic field. Now the probe turns to solving more of the megaplanet's mysteries. Why is the center of Jupiter a jumbled mix of gas and rock? And how does it unlock the birth of the largest planet in the solar system? Jupiter is the largest and most extreme planet in the solar system. NASA's Juno probe is on a mission to unlock its secrets. Juno's next objective is to reveal for the first time what lies at the center of Jupiter. Astronomers believe that a picture of what is happening at the heart of the planet will solve one of its biggest mysteries. How was Jupiter born? Solving this puzzle rests on astronomers finding out if Jupiter has a core made from rock or a core made from gas.
If the core is rocky, then that means that it formed like the other planets in the inner solar system form. Planets like Earth, smaller objects colliding together and stuck together until you built up a planetary-sized body.
A core made from gas will tell an entirely different story of Jupiter's creation. It will be evidence that Jupiter was born through the collapse of a giant cloud of gas and dust in the early solar system. Instruments on board Juno measure the shape and size of Jupiter's magnetic and gravitational fields to find out. Astronomers on Earth crunch this data to build up a detailed image of what lies at the heart of the megaplanet. They discover that the interior of Jupiter is far stranger than anyone could have imagined. Jupiter's core is not exclusively rock or gas. It's a weird mixture of both.
It seems to have a lot of rocky stuff and metal stuff, but it also has a lot of gassy stuff. So it's not like a distinct entity, it just sort of fades away with distance from the center. It's really just kind of fuzzy.
Many astronomers think this new evidence indicates that Jupiter is born as a rocky planet. It then accumulates huge quantities of gas to grow to the size it is today. But what causes the rock and gas inside Jupiter to mix and make a fuzzy core? One theory is that a young Jupiter is involved in a cosmic crash. What is the object that crashes into Jupiter and shatters the core of this mighty planet? Planetary scientists have a way to find out. They build models of the early solar system inside supercomputers. They then smash objects into virtual Jupiters to test what type of collision produces the fuzzy core that Juno sees. The researchers discover that just one scenario results in the weird mix of rock and gas at the center of the megaplanet. 4.5 billion years ago, a rocky planet 10 times more massive than Earth heads straight for Jupiter. The planet collides head-on. It plows through the atmosphere towards the heart of Jupiter and smashes the rocky core at the center of the gas giant into billions of pieces. These fragments mix with the surrounding metallic hydrogen to make the weird fuzzy core that Juno detects. The theory works inside a computer simulation. But how is it possible in reality for Jupiter to collide with another planet? The answer could lie with alien worlds, light years away from Earth. Astronomers call them exoplanets. In 2017, astronomers discover a super strange exoplanet orbiting the star Kelt 9. 670 light years away from Earth. Astronomers named this weird world Kelt 9b. Kelt 9b is a gas giant like Jupiter, but it is 11 times closer to its star than Mercury is to our Sun. Astronomers call these types of planets hot Jupiters. Measurements from the Spitzer Space Telescope reveal that this extreme heat is ripping apart Kelt 9b.
The heat from its star is blowing its atmosphere away like a comet. It's losing its atmosphere over time, which means that eventually it's all going to go away. And at some point in the future, all that's going to be left is whatever core this planet has.
Kelt 9b and other hot Jupiters are enigmas. The science says that these huge planets can't form this close to a star. Kelt 9b must have moved towards its star after it forms in a colder region of space. How does this characteristic of hot Jupiters reveal why our Jupiter collides with another planet? And can an epic journey across the solar system solve the mystery of how Earth got its oceans? NASA's Juno probe discovers that the center of Jupiter is a weird mixture of rock and gas. Astronomers believe that a collision with another planet could explain this fuzzy core. Telescope observations reveal that Jupiter-like worlds and other parts of the galaxy move towards their stars. These journeys could solve the mystery of how our Jupiter collides with another planet. 4.5 billion years ago, Jupiter forms in a disk of gas and dust that surrounds the newborn sun. It forms early in a solar system that is a mess of rocks and planetary embryos. The gravity of the disk itself gradually, over a few million years, pulls Jupiter towards the sun. Jupiter advances towards its star with every new orbit. As it moves inwards, Jupiter is a wrecking ball for everything in its path. Jupiter is on the fast track to becoming a hot Jupiter. One theory is that another planet comes to the rescue.
The Jupiter we have today almost didn't exist, but luckily for it, Saturn formed close enough to it and its gravitational attraction slowed it down, so it saved it from the fate of moving in closer to the sun than Mercury even is and then getting boiled away.
Many astronomers believe that Jupiter's journey towards and then away from the sun stirs up the protoplanets in our solar system. Some of them change places and switch orbits. The mayhem that Jupiter unleashes could explain how one such planet ends up on a collision course with the gas giant. Data from Juno unlocks the mysteries of Jupiter's early history. Scientists now think that Jupiter's migration is a defining event for our solar system. How does Jupiter's journey shape the solar system that we know today?
Jupiter is the largest, the most massive planet in the solar system. Clearly, it has profoundly affected everything else around it. The mystery is, how? In detail, specifically, what did it do?
A fuzzy core is evidence that Jupiter collides with a giant planet during an epic migration across the solar system. The gravity of Saturn pulls Jupiter back and saves the megaplanet from becoming a hot Jupiter. Scientists think that this journey might unlock one of Earth's biggest mysteries. How did oceans form on our planet? The young Earth is born dry around 4.5 billion years ago. Its close proximity to the sun means that lighter ingredients like water evaporate into space. Astronomers think that the source of water on Earth lies in a frozen region of space farther away from the Sun. When the Sun ignites, its heat creates a water-free zone around it. The Earth forms dry in this barren region of space. Further out, near Jupiter, orbit millions of asteroids. Here, it is cold enough for water to exist as ice. Water freezes inside the asteroids. They smash together to make bigger space rocks that contain vast amounts of water. Enough to fill entire oceans if they were to hit Earth. But what sends them flying through space towards our planet? And is it possible that these rocks also contain the building blocks of life? Astronomers believe that a bombardment of water-rich asteroids billions of years ago seeds Earth's oceans. But what sends these space rocks flying towards our planet? A clue is locked inside meteorites. Meteorites are fragments of larger asteroids in space that break away and fall to Earth. The tiny grains of dust inside meteorites tell astronomers where in the solar system their parent asteroids are born. Astronomers find both wet and dry meteorites on Earth. If these two types of space rocks form inside asteroids in different areas of the solar system, then it is evidence that something in the past jumbles them together. Scientists believe only one object in the solar system is powerful enough to mix together entire asteroid fields: Jupiter.
As Jupiter migrated, objects were thrown to higher orbits, lower orbits, into the Sun, out of the solar system. It really mixed things up.
Around 4.5 billion years ago, Jupiter is on its return journey away from the Sun. The planet passes through separate regions of dry and wet asteroids. Jupiter's huge gravity flings these space rocks across the solar system. The mix of asteroids bombard the young Earth. It's possible that these frozen rocks bring with them the water that forms our planet's oceans. Scientists think it is possible that the asteroids that Jupiter flings at Earth bring more than just water. In 2015, NASA's New Horizons probe visits a strange body way out in the farthest reaches of our solar system. The cameras on the probe send back photos of Arrokoth, a misshapen object in the Kuiper Belt, a ring of billions of space rocks beyond the orbit of Neptune. Some of the images reveal that a strange red tar-like substance covers parts of the surface of the frozen object. Analysis reveals that these red areas contain organic chemistry. These chemicals are the raw materials for making amino acids, the building blocks of DNA. Some scientists think that the frozen water locked inside the asteroids that bombard the young Earth contain these seeds of life.
Given all that Jupiter did to the solar system and its destructive power, it's quite a surprise to find that it may be what delivered the goods to Earth that were necessary for life to get started on our planet.
NASA's Juno probe is unlocking the mysteries of the largest and most extreme planet in the solar system. The mission reveals that Jupiter is more alien and more powerful than astronomers ever thought possible, and that this gas megaplanet plays a leading role in shaping the solar system we see today.
We always knew that Jupiter was extreme, but now with Juno flying above its beautiful clouds and peering deep into its heart, we have an idea of what makes this guy tick.
From its supermassive, ever-changing magnetic field to its super-powerful megastorms that reach deep into the atmosphere, and its fuzzy core, the echo of an ancient collision with a giant planet. Thanks to Juno, Jupiter is finally giving up its secrets.